Hi. This video we are given a graph. Now this is the graph we are given, and then the question demands that we find the formula of this quadratic I said quadratic, sorry for that. The formula of this function here. We do not know the graph. What kind of function has this kind of graph? We do not know, but all we know is by our knowledge of properties of a function, we want to determine the polynomial that has this graph. The very first thing you would observe is the x-intercept. That is the x-intercept we have here. We have one here, so let me use a different color. Let me choose this color. So we have one here. This is one. This is another intercept, and that x-intercept, and then this is another x-intercept. So we have three x-intercepts. So the first x-intercept is for x equals 0. The next one is for x equals 1, while the last one is for x equals 2. So these are the three x-intercepts that we have. Alright, so let me go back to the function here. So we have f of x. So we want to determine the formula for f of x. So now what we know is the zeros of f of x, they are x equals 0, like we have seen here. We have x equals 1, and then x equals 2. Now since x equals 0 is what's the name? Since x equals 0 is 0 of this function, so that implies that x minus 0 is a factor of this polynomial. Since x equals 1 is a 0 or is an x-intercept of this function here, so that implies that x minus 1 is a factor. So what I'm just doing is I'm just bringing 1 to the other side here, and then if you bring this to the side here, you have x minus 2 equals 0. So like I said, the zero, that's what it means. So similarly, x equals 2 implies x negative 2 is a 0 of this function here. So I already have a very good format for f of x. So my f of x could be written as x minus 0 is x into x negative 1 into x negative 2. So this is the first format here. Now what other information can I get from here? Now you'd observe that we have some turning points here. So the very first turning point I have here is this is the turning point. You can see this is a turning point. So this is 1. This is another turning point. This is 2. That's all. Those are the only two turning points we have. So that means the graph here has two turning points. So two turning points. So we have two turning points. Now let's go back to something we know. Any polynomial, say a polynomial f of x that is of degree n. If a polynomial is of degree n, then it can have at most that is a maximum of n minus 1 turning points. N minus 1 turning points. Now the function we have here has two turning points, 2. So that is our n is 2. So if n, I'm sorry, I said 2. So that is n minus 1 equals 2. So if n minus 1 equals 2, so that implies that n equals 3. So that is to say the degree of the polynomial should be 3. Now when we come here, we observe this is x times x squared times x is going to give us x cubed. So that implies that the degree of this polynomial here is x cubed. So you shouldn't do any other thing again. So that should tell you that the formula for this polynomial is going to be f of x equals x into x negative 1 into x negative 2. So this is the polynomial that has this graph. And then to be very sure of your answer, you will observe that at this point here and at this point here and at this point here, the graph crosses. So since it crosses, the multiplicity is going to be odd. It's going to be odd here, and it's going to be odd here. It has to be odd. So since the power here is 1, the multiplicity here is 1. It's odd. The power here is 1. The power here is 1, which is an odd number. So the multiplicity, this is the multiplicity of this the 0 here is 1, which is odd. So that's true. Here is 1, which is odd, and here is also 1, which is also odd. So that verifies that your answer is correct. And this is a very simple example. Maybe in the nearest future we might just consider a different kind of function that might be a little challenging to some students. But if you have any question here, you could just drop your questions in the comment box below. Thank you for watching.